Hi there, and welcome to this lesson. In this lesson, we'll be learning properties of circles. Okay, we'll be learning about circles, and on the properties of circles, we'll be learning about arcs and sectors. Okay, so arcs and sectors. Now, as the lesson progresses, anything you don't understand, be sure to contact your tutor, who would be more than happy to help. And yeah, let's jump right into the lesson. Properties of circles, and so we have this circle, okay, and we're going to label the circle. Okay, there are different, very important parts of the circle, and we're going to talk about those parts now. Okay, so we start off with the first one, diameter. Okay, diameter. I believe at this point you should be somewhat very familiar with diameter. Diameter, basically, it's a line that divides a circle into two equal parts. A line that cuts through the center of the circle. Okay, from one point in the circumference to the other end of the circumference, and it cuts through the center. It divides the circle into two semicircles. So that's the diameter. Now, what about the next one? We'll talk about radius. Okay, radius. The plural is radii. Okay, so radius, and radius goes from the center of the circle to any point on the circumference of the circle. Okay, and the radius is usually half the diameter. So radius from the center of the circle to any point on the circle. So that's R for radius. And then we have chord. Okay, so basically I think everybody's familiar with radius and diameters, but then what about chords? What is a chord? A chord in a circle. Now, a chord is a line that goes from one point on the circumference to another point on the circumference. Okay, it's a line that divides the circle into two unequal parts. Okay, it doesn't matter where it doesn't have to cut through the center like the diameter. The diameter must cut through the center and must divide the circle into two equal parts. But the chord can just cut through anywhere. Okay, from one end of the circumference to another end, and would divide the circle into two very unequal parts. Okay, so that's a chord. Okay, and now let's talk about arcs. Okay, an arc, and basically an arc is just a cutout of the circumference. Okay, so at any point at all, just any distance along the circumference that you take out is an arc in that circle. Okay, so it could be 99% of the circumference. It could be 1% of the circumference, but any part of the circumference that you take out of the circumference of the circle is an arc. Okay, and then we have sector. Okay, so we've been talking about length. Now we're going to talk about area. Now the sector of a circle is an area bounded by two radii. Okay, and basically I have another radius there. Okay, and it's this area here, an area bounded by two radii, and basically this is our sector. Okay, and basically the sector is just a portion of the circle by area. Okay, bounded by two radii. Okay, usually starts at the center and goes to the circumference. And then finally, segments. Okay, segment, just like sector, we have big S for sector, small s for segment. Now, segment, just like sector, is another area. Okay, another part of the area of a circle, but then it's not one bounded by two radii, or it doesn't have anything to do with coming from the center, all of that. Basically, a segment is just pretty much any part of the circle that you just cut out. Usually cut out using the chord, and you have this as a segment of the circle. It could be anywhere, just cut from anywhere on the circle. It does not go to the center the same way the sector does. So you have a segment there. Okay, and then yeah, that's pretty much it. Now basically we're going to be learning about the properties of a circle. Okay, we're going to learn the relationship between some of these parts of the circle. And yeah, let's start off with the length of an arc. So we start off with an arc, with the arcs. Okay, so we have the length of an arc, and the length of an arc is actually very, very simple. Something very easy to understand. So if you pick out an arc from the circumference of a circle, that arc constitutes a fraction of the circumference of the circle. Okay, and that fraction is dependent on the angle at the center. Okay, so if you pick from where the arc stops and where the arc starts, if you draw two radii from those points down to the center, basically you'd form an angle. And the bigger the arc is, the bigger this angle. Okay, so the bigger this angle, basically, the bigger this angle is, the bigger the arc. Okay, and if you look closely, basically this angle could be pretty much anything from 0 to 360 degrees, because 360 degrees represents the full circumference. Okay, and then any fraction, you could have 90 degrees. 90 degrees would be a quarter of the circumference. We have an arc, the length of a quarter of the circumference. 180 degrees, you'd have a semicircle, so it will be half the circumference. And you actually keep doing this. And basically, the formula for finding the length of an arc is just the formula for finding the circumference of a circle times the fraction of that angle. So basically, you have the angle divided by 360, because the angle is a fraction of 360, and then you multiply that fraction by the formula for, you multiply that by the circumference of the circle. So the length of an arc is theta over 360 times 2 pi r. Simple. Now, what about the area of a sector? The area of the sector follows the same principle. So you have a particular sector, okay, and the sector there, the size of that sector, the area of that sector is dependent on the angle at the center that forms this sector, and the bigger this angle is, the bigger the area, and the angle that represents the full area of the circle would be when a radius has rotated from the start back to itself, and you have that as 360 degrees. So the area of a sector is a fraction of the area, the full area of the circle, just as the angle is a fraction of 360 degrees. And quite simply, basically, you have that the area of a sector is theta divided by 360. So the angle divided by 360 times pi r squared, which is the area of the full circle. And that's it. That's all we're going to be doing in this lesson. Okay, let's go ahead and do some examples. So we have find the length of an arc in a circle of radius 10 centimeters if it subtends a 60-degree angle at the center of the circle. So radius of the circle is 10 centimeters, angle at the center is 60 degrees, and we're looking to find the length of the arc. So we just multiply 60 divided by 360 times the perimeter of the circle. Okay, 60 divided by 360 will give us the fraction of this arc. So what fraction of this arc compared to the full circle? And then basically we have length of an arc is theta over 360 times 2 pi r. R in this case is 10 centimeters. Theta is 60 degrees, and we just go ahead and say 60 divided by 360 times 2 times 22 over 7 times 10. And what we have in the end, we have the length of this arc as 10.48 centimeters. Okay, let's move on. Example 2. Okay, so a bicycle wheel of radius 60 centimeters rolls along the ground the distance of 110 centimeters. Now find the angle through which the wheel has turned. What is this about? It's this, okay? So basically we have this wheel, all right? And as a wheel is rolling on the floor, basically you have a wheel rolling on the floor. It's basically for every distance it's covered on the floor, it moves through, it rotates through a particular angle that basically just the distance covered is equal to the length of the arc on the wheel. Okay, basically that through when it moves through a particular angle. If you just look at the diagram, basically you have a distance of 110 covered. What this means is this wheel has turned through 110 centimeters along its circumference, okay, to cover this distance. And then basically we're looking to find the angle that it has rotated through. Okay, and basically what this is we are given the length of the arc, we're given the radius of the circle, and we're looking to find the angle at the middle. So we have length of arc equals theta over 360 times 2 pi r. If we work change of subject formula there, we'd have theta equals 360 times the length of arc divided by 2 pi r. We have length of arc as 110 centimeters and r as 60 centimeters. And we just go ahead and work our angle to be 105 degrees. Simple, straightforward. Let's move on. Final example, find the area of a sector in the circle of radius 42 centimeters if the angle at the center is 45 degrees. So we just have 45 divided by 360 times pi r squared. So 45 divided by 360 times pi r squared, and when we do that we end up with an answer there. And yeah, that's it. Very simple, very straightforward. So just something you need to remember for the arcs and the sector. Basically they correspond to the circumference and the area. Okay, and basically the angle represents a fraction of each of them. Okay, so for the arcs, the angle represents a fraction of the circumference, and then for the sector the angle also represents of what tells you what fraction of the area of the circle you're dealing with. And that's pretty much it. You can go ahead now and attempt questions on the worksheet. Bye for now.